Hello everyone, welcome to this channel. Today we are going to see concurrency control part 3. In this we are going to start with two-phase locking protocol. Since we have already seen lock-based protocol in a previous video. So what two-phase locking protocol is telling us? It is going to guarantee serializability. Serializability means what? Transaction can be executed in such a way that the result are same as if each transaction actions were executed in a sequence without any interruption. साइमल्टेनियसली जो ट्रांजैक्शन एग्जीक्यूट हो रहे हैं उनका आउटपुट एग्जैक्टली सेम होगा जैसे वो एक के बाद एग्जीक्यूट होते हैं. तो दिस इज व्हाट द कॉन्सेप्ट ऑफ सीरियलाइजेबिलिटी, राइट? तो हियर इन टू फेज लॉकिंग प्रोटोकॉल each transaction issue a lock and unlock request in two phases. There are two phases over here, growing phase and shrinking phase. What happens in growing phase? A transaction can obtain locks but cannot release any lock. जितने भी लॉक्स उसको चाहिए वो ग्रोइंग फेज में ले लेगा, ठीक है? और इस वक्त वो कोई लॉक को रिलीज नहीं करेगा. श्रिंकिंग फेज में क्या होता है? A transaction can release locks but cannot obtain any new lock. Okay? Shrinking phase में वो लॉक को रिलीज करना शुरू करेगा, पर इस दौरान it is not going to acquire any new lock, right? Let's see. Initially, the transaction is in growing phase. In this, it acquires locks as needed. Once the transaction releases a lock, it enters the shrinking phase and it cannot issue no more lock request. The point in the schedule where the transaction has obtained its final lock, the end of its growing phase, is called the lock point of the transaction. So here you can see the example diagrammatically over here. Okay? And we are going to see the example also in the next slide. So basically see here how your schedule is looking. It is having growing phase, it is having lock phase, and it is having shrinking phase. Right? Growing phase means what? The transaction acquires lock, keep on acquiring lock. See here, you can see acquire lock, right? Now, this is the last lock and this is the lock phase. This is the last lock and this is the lock phase, okay? After this, the transaction keep on releasing the lock, okay? That means what? It has entered the shrinking phase. So here you can see, release the lock, right? So here this is what the two-phase locking protocol is having, growing phase and the shrinking phase. Growing phase acquires as many locks as it is needed to execute the transaction. And here shrinking phase, it keeps on releasing the lock as the work of that data item has finished, right? So these are the two phases and this is the example. T1 and T2, here you can see this is the T1. जितने भी locks उसको चाहिए, it has acquired the lock on data item B, it has acquired the lock on data item A. Okay. Once it has completed the work on those particular data item, then it has entered into the shrinking phase. You can see this is unlock B and unlock A, right? So this is what the growing phase of that particular transaction. Okay, and here once it started releasing the lock, then it has entered into the shrinking phase. Okay, so these are what the two-phase locking protocol. Likewise, here also in transaction T2, you can see it is locking data item A, it has locked data item B, and this is what the shrinking growing phase, and this is what the shrinking phase of that particular transaction T2. Okay, so this is what the concept of two-phase locking protocol. Now here, two-phase locking protocol does not ensure freedom from deadlock, right? Transaction T1 and T2 are the two phase, but they are deadlocked in the schedule, okay? Here you can see this is two-phase locking protocol. These two transactions are in two-phase locking protocol, but here it is not free from deadlock. It is not free from deadlock. Here T1 is waiting for T2 and again T2 is waiting for T1. Okay, that's why here cascading rollback may occur under two-phase locking protocol. So this is what the drawback of two-phase locking protocol since it is not ensuring freedom from deadlock. That's why here cascading rollback may occur under two-phase locking protocol, right? So this is what the deadlock. This is what the deadlock. If both the transactions are waiting for each other, then this is what the deadlock. And because of this, cascading rollback may occur under two-phase locking protocol. Now, what is cascading rollback? A cascading rollback occurs in database system when a transaction T1 causes a failure and a rollback must be performed. Other transactions dependent on T1's actions must also be rolled back due to T1's failure, thus causing a cascading effect. That is, one transaction failure causes many to fail. तो दिस एक ट्रांजैक्शन फेल होता है और वो ट्रांजैक्शन के ऊपर जितने भी ट्रांजैक्शन डिपेंडेंट है वो सारे के सारे रोल बैक होंगे, राइट? तो बिकॉज ऑफ फेलिंग ऑफ वन ट्रांजैक्शन देयर आर failures of so many transactions. To this is what the cascading effect. So all the transactions must be rolled back, right? So this is what the cascading rollback. Okay. Now, as there was a drawback in two-phase locking protocol, that's why there were some variations which were generated for two-phase locking protocol. First one is strict two-phase locking protocol, strict 2PL. Cascading rollback can be avoided by a modification of two-phase locking called strict two-phase locking protocol. In this protocol, all exclusive locks of a transaction must be held until that transaction commits. This prevents other transaction from reading wrong data. Okay? This prevents other transaction from reading wrong data. Okay? So basically, what is strict two-phase locking protocol telling? ट्रांजैक्शन दोज आर हैविंग एक्सक्लूसिव लॉक, ये कब तक होना चाहिए? जब तक ट्रांजैक्शन कमिट नहीं होता है, राइट? दैट्स वाई दिस इज डेफिनेटली गोइंग टू प्रिवेंट अदर ट्रांजैक्शन फ्रॉम रीडिंग रॉन्ग डेटा, राइट? तो हियर सेकेंड वन इज व्हाट? रिगरस टू फेज लॉकिंग प्रोटोकॉल. It requires that all locks, shared or exclusive, to be held until the transaction commits. Okay? Shared or X to be held until the transaction commits. So here you can see this is the example over here. T1 and T2 are the two transactions over here. T1 has acquired lock on the data item A in shared mode, right? Transaction commit jahan par hai, you can see here the commit message is there. After this only the lock will be released, either shared or exclusive. Okay, either shared or exclusive. Right. Once the transaction has commit, then only the locks will be released. This is what the rigorous two-phase locking protocol. Okay. Next is what? Conservative two-phase locking protocol or static two-phase locking protocol. It requires the transaction to lock all the items it accesses before the transaction begins execution. Okay. If any of the data items cannot be locked, the transaction does not lock any item. Instead, it waits until all the items are available for locking. And conservative two-phase locking protocol is a deadlock-free protocol. So basically, what is the concept of conservative two-phase locking protocol? जितने भी लॉक्स उसको लगने वाले हैं, जितने भी डेटा आइटम्स उसको लगने वाले हैं, वो ट्रांजैक्शन को कंप्लीट होने के लिए इट इज़ गोइंग टू एक्वायर लॉक्स ऑन द डेटा आइटम बिफोर द ट्रांजैक्शन बिगिंस. ओके, एक भी डेटा आइटम के ऊपर वो लॉक ग्रांट नहीं कर पाया, right, then it is not going to lock any of the data item. Instead, it is going to wait until all the items are available for locking. So definitely this is free from deadlock. Okay, so this is the example of conservative two-phase locking protocol.